Hi everybody, in this lesson we are going to be looking at section 3.1 of the trigonometry book. We're going to learn about radian measures of angles. We're going to learn how to convert between degrees and radians and how to find function values for angles that are measured in radians. So here we go. First, let's figure out exactly what a radian is. If you take an angle that has its vertex at the center of a circle, so we'll put it at the origin right here, and that angle covers an arc that's the same length as the radius, then this angle is equal to 1 radian. Notice that the radius here is r, and the part of the circle that it covers is equal to length r. So that makes an angle of 1 radian. Now what we have here is a circle that's been marked off with radius lengths. So here's the radius, okay? And now each of these marks represents a length of 1 radius. So from 0 to 1 is 1 radius, and from 1 to 2 is another radius equal to the radius. Now let's make our angle where the angle covers 1 radius worth on the circle. Now this angle we learned on the last slide is called a radian, and let's see how many radians there are in a circle. This 1 radian here is of course less than 90 degrees. If I add a radian to that, you can see that 2 radians are a little more than 90 degrees. Let's go to 3 radians. You can see that 3 radians are nearly equal to 180 degrees, but not exactly. And 4 radians, 5 radians. 6 radians is an angle that's nearly equal to 360 degrees, but not quite. Not quite. There's a significant gap there. So, you know what? It makes it very inconvenient to count radians in whole numbers because the whole numbers of radians don't seem to line up with any of our special angles. 1 radian is just a little bit short of 60 degrees, and therefore the whole thing is thrown off. Our 3 radian mark is not exactly 180, and our 6 radian mark is not exactly 360. So that becomes a little inconvenient. How can we solve this problem? Well, one way we could solve that problem is by thinking about the circumference formula. You are all familiar with circumference equals 2 pi times the radius. Well, another way to think about this is that the circumference, or 1 revolution around the circle, is equal to 2 pi times the radius length. Well, we know that the number of radius lengths is the number of radians. So this formula is telling us that 1 revolution around the circle is equal to 2 pi radians. So think about this. Pi is 3.14 approximately. So 2 times 3.14 is 6.28. And doesn't that fit with what we saw here? 1 revolution around the circle is a little more than 6. So I think we're on to something. So instead of counting radians in whole numbers, we tend to count radians in multiples of pi because of the circumference formula. That's just the way it works out. So we can say that 360 degrees is equal to 2 pi radians. Now, instead of a whole revolution, we could talk about a half revolution. Well, if 1 revolution is 2 pi radians, then half a revolution is going to be half of 2 pi radians. In other words, 180 degrees is equal to pi radians because the 2's cancel and we're left with just pi radians. Now think about it. Pi is a little more than 3, and when you look at the circle, sure enough, 180 degrees is slightly more than 3 radians. So let us look now at the circle, the same circle, that is measured not in whole numbers of radians, but in multiples of pi. This circle is labeled in half pi's. You can see the top of the circle is 1/2 pi, and that makes sense because halfway around the circle is a whole pi. And then the bottom of the circle is 3/2 of pi, and all the way around the circle would be 2 pi. So they didn't label it here because it's labeled 0, but since 2 pi is equivalent to 360 degrees, 0 radians is coterminal with 2 pi radians. Now that we understand that 180 degrees is equal to pi radians, we're going to be able to convert any angle from radians into degrees or from degrees into radians. We do that by using what's called a conversion factor. We know that pi radians is equal to 180 degrees. Therefore, if we make a fraction out of those two numbers, it's really a fraction that's equal to 1. It doesn't look equal to 1, but because the pi is measured in radians and the 180 is measured in degrees, it really is equal to 1, and multiplying by this conversion factor will change a number from degree measure to radian measure. And if we turn that conversion factor upside down and have degrees on top, we can convert any angle from radian form to degree form. Because what happens is, if your angle is in degrees and you put your conversion factor where degrees is on the bottom, the degrees will cancel and the unit radians is left over. If you have an angle in radian measure and you put radians on the bottom, degrees on the top, the radians will cancel and your answer will be left in degrees. And now on the next couple of slides, we're just going to practice with that idea and see if we can get good at converting from one form to the other. This is example 1 in your notes. Convert each degree measure to radians. So I'm going to start with 45 degrees. Now it's in degrees, so I want it in radians. So the conversion factor that I use has radians on top, degrees on the bottom. The degrees will cancel out because I have degrees in the top and the bottom. They cancel, and we're left with 45 pi over 180. Now 45 over 180 is a fraction that can be simplified. So we should do that either mentally or on the calculator, and the final answer comes out pi over 4. 45 over 180 reduces to 1 over 4. So this is written as pi over 4. Now let me show you on the calculator. If you use this button on your calculator that looks like A, B over C, it looks like a mixed number. That's the fraction button. So if you enter 45 fraction 180 and press equal, the calculator understands this as a fraction, and it will reduce it for you to 1/4. Alright, now let's try negative 270 degrees. So again, we use our conversion factor of pi over 180. The degrees cancel out, and I didn't even put the degree symbol here, but the degrees would cancel. Our fraction would come out negative 270 pi over 180. On your calculator, you can reduce negative 270 over 180, and you will get negative 3 over 2. So this fraction, because of the pi here, becomes negative 3 pi over 2. Okay, now this part C is in decimal form. So when we multiply by our conversion factor, the fraction that we get is not very pretty, and it is not going to reduce to a nice one like one of these. In this case, what we do is we use the decimal form of pi and go ahead and get into an approximate form. So on my calculator, instead of reducing this fraction, I'll push 249.8 times pi divided by 180. And we end up having to round that off because, of course, pi is irrational. It has an infinite supply of decimal places. And so I've just rounded off here to 2 decimal places. This is approximately equal to 4.36. And I hope you're trying this on your calculator. And so because that angle was measured in decimal degrees, we treat it as approximate, and our answer comes out in approximate form. You see these were exact degrees, so our fraction that we get is a nice one that can be simplified, but in case it's not a nice fraction that can be simplified, we usually go to approximate form. Now let's talk about converting from radian measure back into degrees. So here I have 9 pi over 4 radians. Now normally we wouldn't even label it radians. We always use the degree symbol for degrees, but normally radians are not labeled at all. So we'll just take our 9 pi over 4, which we understand to be in radians. We'll multiply that by 180 degrees over pi. Now this time the radians cancel and the answer will come out in degrees. So look, what else cancels? The pi's are also going to cancel. And we are left with 9 times 180 over 4, which your calculator reduces to 405 degrees. Let's do the same thing for this one. Negative 5 pi over 6. We multiply by our conversion factor. We want the answer to come out in degrees, so we put the 180 degrees on top. Radians cancel, pi's cancel, and we are left with negative 5 times 180 over 6, which reduces to negative 150. And part C is decimal radians, 4.25 radians. So I would say this is already in approximate form because it's not, we know radians are usually measured in multiples of pi, and this is not, so I'm going to treat it as approximate form. We still use the same conversion factor, 180 degrees over pi radians, but this time I have no pi's to cancel, so I'm kind of forced to go into approximate form. We end up punching 4.25 times 180 divided by pi on the calculator, and it is approximately 243.51 degrees. That's approximate because, of course, pi produces lots of decimal places and we have to round off. So because we started in approximate form, our answer comes out in a rounded off form. So just another word about how you know when to use exact form or approximate form. You always have a choice. If you stay in exact form, you'll have pi notation in radians and you'll have to simplify a fraction. If you go to approximate form, you're going to have decimal places and you probably need a calculator to do that for you. If possible, we usually stay in exact form. Nearly everything we do is going to be measured in exact form, but watch for instructions that tell you which to use, and of course if you see decimals, you know you're going to end up in approximate form. Now I'm pretty sure that I've mentioned this already, but I just want to reiterate that if no unit of angle measure is specified, then the angle is understood to be measured in radians. You cannot assume that an angle is in degrees just because it looks like it's in degrees. If it does not have the degree symbol, you must assume that it is in radians. Now, using the conversion factors is all well and good, but it can be a little cumbersome sometimes. So what I want to do instead is for our special angles, anything that's a multiple of 30, 45, 60, or 90, or of course 180, I want to be able to convert quickly mentally without a calculator and without using the conversion factor. So let's take a look at these 4 conversions plus the pi equals 180, which we already knew from the previous slide. This is how we defined radians in the first place. If pi is equal to 180 degrees, then it makes sense that half of pi is equal to half of 180 degrees. A third of pi should be equal to a third of 180 degrees. A fourth of pi equal to a fourth of 180 degrees. And a sixth of pi equal to a sixth of 180 degrees. So those 4 simple calculations get us conversion factors for each of our special angles. Well, this is good news, because now if you have these 4 facts memorized plus the pi equals 180 degrees, then it's easy to convert. If you want to convert from degrees to radians, what you'll do is write your degree angle as a multiple of one of your special angles, and then exchange the special angle for its radian equivalent. On the other hand, if you want to change from radians to degrees, exchange the special angle, which will look like one of these, for its degree equivalent, and then multiply times the remaining coefficient. I know it looks really horrible in words, but you'll see that in practice it's quick and easy to do. You won't need a calculator, and it won't slow you down at all. Here I've taken some problems from the end of the section. We'll just do a few together, and on these we will not use the conversion factor, the pi over 180, but instead we will use our conversion factors that we just learned on the last slide, and we will do this mentally without a calculator. So let's look at 120 degrees. Now I know I'm trying to write 120 degrees as a multiple of one of these degrees, and I know that 60 will go into 120, but also 30 will go into 120. If you ever have a choice, use the larger factor. So 60 goes into 120 two times. We can write 2 times 60 degrees. Now we trade the 60 degrees for a pi over 3, and we now see that 120 degrees is equal to 2 pi over 3 radians. And it is that simple. Let's do the same thing for 150 degrees. We know that 150, 30 will go into 150, so it's 5 times 30. And then I can trade the 30 degrees for a pi over 6. And so 150 degrees is equal to 5 pi over 6 radians. Notice I don't write the word radians. Let's do negative 300 degrees. Well, of course 30 will go into 300, but remember I said when you have a choice, always use the larger number. So 60 will also go into 300. So let's write negative 300 as negative 5 times 60 degrees. And then we'll trade out pi over 3 in place of our 60. And so negative 300 degrees is equal to negative 5 pi over 3 radians. And for 315, that happens to be that 45 goes into 315. We will write that as negative 7 times 45. And then we'll trade 45 degrees for pi over 4 radians, and that conversion is finished. Here are a few more problems from the same page in the book, only for these problems we're going from radians back into degrees. And I'm going to start with 8 pi over 3. And I notice that pi over 3 is one of the radian equivalents that I have memorized. Pi over 3 can be written as 60 degrees. So 8 pi over 3 becomes 8 times 60, which is 480 degrees. And now let's look at 7 pi over 4. We recognize pi over 4 as one of our radian equivalents, so we'll write 7 times pi over 4 equals 7 times 45 degrees, because that's an even trade, and then 7 times 45 is 315 degrees. For 11 pi over 6, we will trade out the pi over 6 for 30 degrees, and 11 times 30 degrees is 330 degrees. And for 11 pi over 30, you know 30 doesn't match any of my denominators over here, so in this case I would just go back to the old-fashioned conversion factor that I showed you in the beginning, and I would cancel out the pi's and multiply 11 times 180 divided by 30, and that would be 66. Now, of course, anytime I ask you to memorize something, I always give you a way in Quizlet to review that easily. So here are all of the angle equivalents that you should be able to call up quickly, and I have a Quizlet set of flashcards that will help you practice that conversion that we were just doing on the last slide. And so I recommend, instead of memorizing all of these, that you just learn how to do the mental conversion quickly. And I want you to practice that in Quizlet, and of course the link is available for you in my math lab. Just click on videos and notes. Now I just have one more example to do with you in this section. We're going to be finding function values for angles that are measured in radians. So for these types of problems, we will have to pull together everything we know about finding function values of non-acute angles. We learned all about that in Chapter 2. And we'll put that together with what we know about radian conversions. And together, it just all goes together. You need to make one seamless process out of it. If there's anything you still don't understand from Chapter 2, this is going to be very frustrating until you get that all squared away. And then this will be easy. So I hope that you've already taken care of that. And let's go ahead and look at the tangent of 2 pi over 3. Now, pi over 3 we recognize as 60 degrees. So let's mentally convert from radians to degrees. I'll say 2 pi over 3 is equal to 2 times 60 degrees, which of course is 120 degrees. That tells me that the tangent of 2 pi over 3 radians is equal to the tangent of 120 degrees. Now here I've sketched out 120 degrees, and I can see that the reference angle is 60 degrees. So I know that the tangent of 120 is the same number as the tangent of 60, but it's going to be negative because we're looking at a tangent value for an angle in quadrant 2. So let's say the tangent of 120 is negative square root of 3. Now let's do sine of 3 pi over 2. So I need to get a feel for where is the angle 3 pi over 2. Well, I know it's a quadrant angle because it's a multiple of 90 degrees. So 3 pi over 2 is 3 times 90, which is 270 degrees. If I sketch that, I can see that it's the terminal sides on the negative y-axis, and the point on the unit circle is 0, negative 1. And that's important to know because for all the quadrant angles, the sine is the vertical coordinate. And so we're going to say the sine of 3 pi over 2 is equal to negative 1. And for the last one, cosine of negative 4 pi over 3 will convert negative 4 pi over 3 to negative 4 times 60 degrees, which is negative 240 degrees. Now remember, we have to go clockwise for that, and the reference angle will be here between the terminal side and the nearest horizontal. So the reference angle is 60 degrees. And therefore the cosine of negative 4 pi over 3 is equal to the cosine of 60, but it needs to be negative because we're in the second quadrant. So it's going to be negative 1/2.